This is R.D. Sharma solution, class 12, chapter 19. Exercises 19.23. We are taking indefinite integrals. Now in this exercise, we will be using a lot of trigonometry. So the trigonometric identities, wherever it will come, I will write it. I will show it to you so that you learn it for better. Now what do we do? 1 by 5 plus 4 cos x we cannot integrate directly. So we have to devise a plan or devise an approach so that we can make it integrable. We know that cos x is equal to 1 minus tan square x by 2 by 1 plus tan square x by 2. Because cos 2x is 1 minus tan square x by 1 plus tan square x. You already know that. So I'm just writing it because this is going to be used a lot in the other questions which are going to be followed. So I'm just showing you the denominator right now. It's 5 plus 4 and here I'm writing this one 1 minus tan square x by 2 1 plus tan square x by 2. So I'm just writing it in short so that you understand that what exactly this change or this replacement is going out to be. So 5 into 1 plus tan square x by 2, I am just taking the LCM. 4 into 1 minus tan square x by 2. And denominator we have 1 plus tan square x by 2. So 1 plus tan square x by 2. So this is only the denominator which I am talking about right now. So let's resolve this one. 5 plus 5 tan square x by 2 plus 4 and 4 minus 4 tan square x by 2. So what do we got? So 5t square minus 4t square is equal to t square. So it's actually tan square x by 2. 5 plus 4 is 9. So you can write it as tan x by 2 whole square. So this is tan x by 2 whole square and this is 3 square. Now this is just the denominator and this denominator, that is tan square x by 2 plus 3 square divided by 1 plus tan square x by 2. So this 1 plus tan square x by 2 will go up in the numerator. So we have this tan square x by 2 plus 3 square, and since it is 1 by tan square x by 2 plus 3 square divided by 1 plus tan square x by 2, so 1 plus tan square x by 2 will go in the numerator. Now 1 plus tan square x by 2, you already know that sec square theta is equal to 1 plus tan square theta. So we can directly write the numerator as sec square x by 2. And this tan square x by 2 plus 3 square. So it is tan x by 2 and this, because now we are going to integrate it. So this left part only was for your understanding. Actual integration will start from here. Now when we take this t equals to tan x by 2, this dt by dx will be equal to tan x by 2 is sec square x by 2. So sec square x by 2 and x by 2 differentiation will be 1 by 2. So this is 1 by 2. This 2 goes here, so it will be 2 dt will be equal to sec square x by 2 dx, because we actually need sec square x by 2 in the numerator. And this replacement will be what? It will be 2 dt. When we take t equals to tan x by 2, sec square x by 2 will be sec square x by 2 dx will be 2 dt. So I'm writing 2 dt 2 in front of the integration. Now we have taken t equals to tan x by 2, so t square plus 3 square will be. Now we have seen in the previous exercises also, this dx by x square plus a square, the direct result we have, it's 1 by a tan inverse x by a. So this is 2 integration of, and after integration it will be 1 by a. What is a? 3. Tan inverse x by a. What is x here? T. A is 3. So this will be 2 by 3 tan inverse t by 3. So tan inverse, what is t here? T was tan x by 2. So let's write tan x by 2 here and 3 in the denominator. So divided by 3 plus constant of integration. So let me show you the result here. This is the stepwise solution process of the question we have seen, and you need to follow this kind of process. All these English and symbols have to be written. Now we have just dealt with a cos, but now this question is having a sine. So we are now aware that we have to change sign in such form so that this integration is easier. And we know that to sine x is 2 tan x by 2 divided by 1 plus tan square x by 2. So 2 tan x by 2 by 1 plus tan square x by 2, we can write sine x. So 1 by 5 minus 4 sine x, I am writing now the denominator 5 minus 4 into 2 tan x by 2 divided by 1 plus tan square x by 2. So let's write it in short and try to solve what do we get in the denominator. So I'm taking the LCM, 5 into 1 plus tan square x by 2, that is 5 into 1 plus t square, and minus 8 tan x by 2. Please remember 5, this 1 plus t square is with 5. Then we have this 8t, that is t I'm writing for tan x by 2. So we have 5 plus 5t square minus 8t. So 5t square minus 8t plus 5. So let's make it as a perfect square first. Now denominator will also have, because we have just taken the denominator, denominator will also have 1 plus tan square x by 2. So let me write it here. 5t square minus 8t, please remember t is tan x by 2 here. And this 1 plus tan square x by 2 will go up in the numerator. So 1 plus tan square x by 2 divided by 5 tan square x by 2 minus 8 tan x by 2 plus 5. So now let me just replace t by tan x by 2. So 1 plus tan square x by 2 here divided by 5 tan square x by 2 minus 8 tan x by 2 plus 5. So this tan x by 2, let's take it as t. dt by dx will be what? Tan x by 2 is sec square x by 2. And the differentiation of x by 2 will be half. So this will be 2 dt equals to sec square x by 2 into dx. Now this numerator 1 plus tan square x by 2 is already sec square x by 2 because this is the identity. So in place of 1 plus tan square x by 2 you can write sec square x by 2, and then in your denominator you have 5 tan square x by 2 minus 8 tan x by 2 plus 5, and this sec square x by 2 you can write it as 2 dt now. So 2 dt, and sec square x by 2 if it is 2 dt because t was taken as tan x by 2. So this will be 5 t square minus 8t plus 5. Now integration has become so easy because this is the denominator, we just have to make it as a perfect square. So let's make this as a perfect square, 5t square minus 8t plus 5. So 5 I'm taking outside, and the only thing is when you take anything outside it has to be divided by every term. So t square minus 8t by 5 plus 1 has come, because 5t square by 5 is t square, 8t by 5 is 8t by 5, and 5 by 5 is 1. So now 2 dt was there, so 2 I have taken out, 5 we have taken here. So 5 I have taken out, 2 by 5 has come in front of integration. Now this 8 by 5 has to be divided by 2 now and square it. So this is how we add and subtract terms to make it as a perfect square. Take the coefficient of the t and divide it by 2 and square it and add it and subtract it. So you have t minus 4 by 5 whole square, a square plus b square minus 2ab, and then 1 minus 4 by 5 whole square, that is 1 minus 16 by 25. So it will be 25 minus 16 by 25. So this is going to be 9 by 25. It's 3 square and 5 square. So you can write it as 3 by 5 whole square. This is 3 square, this is 5 square, 3 by 5 whole square. So let me write it here now. 2 by 5, you know how this constant we have taken outside. Now dt by t minus 4 by 5 whole square plus 3 by 5 whole square. Now this t minus 4 by 5 can be written as u. du by dt will be equal to what? 1. So du will be equal to dt. So even if you take it as x, because some may ask this question that if you are applying this formula dx by x square plus a square, t minus 4 by 5 is not equivalent to x. It has 4 by 5 content extra. But I showed you that if you take it as u also, some term, du and dt will be equal. So you can take t minus 4 by 5 equivalent to x and apply the formula in the same way. So this shows that t minus 4 by 5 can be taken as only x. So let's use this formula. 2 by 5 was already there. 1 by a, that is 1 by 3 by 5, tan inverse, and x by a, what is x? T minus 4 by 5 divided by and 3 by 5. So let's resolve this, the front thing. This 5 gets cancelled. You have 2 by 3 tan inverse. Now t minus 4 by 5, it will be what? 5t minus 4 by 5. In the denominator we have 3 by 5, so 5 gets cancelled. It's 5t minus 4 by 3. So this will be 5t minus 4 by 3. Now what was t initially? It was tan x by 2, remember? So I'm just writing here. There are certain steps you have to write. I'll show you what you have to do. So 5 tan x by 2 minus 4 by 3 plus constant of integration. And that's your final result. Now this is how you're going to do this. It's very important to write, because knowing is one aspect and writing it on a paper in an examination is very important. So we have just seen a question like this, and there are certain questions we'll do in order to let you know that how it is to be done, and let's see how this question will be done. Now you are aware how to write this sin x. So let me write the formula again so that it stamps on your brain, the neural circuit you have. To 10x by 2 by 1 plus 10 square x by 2, that is how sin x can be written. Now let me just take this 10x by 2 as t, just to show you that how this denominator will be formed. So 1 by 1 minus 2, sin x can be written as 2 10 x by 2 divided by 1 plus 10 square x by 2. I am writing just t for it, just to show you. Now just take the LCM here. So 1 plus 10 square minus 4t. 1 plus t square goes here, minus 2 to the 4t. 1 plus t square in the denominator goes up. So what do you get? 1 plus 10 square x by 2. Now I am just writing actual thing, 10 square x by 2. And then we have 1 plus t square minus 4t. So you can write this as t square minus 4t plus 1. So 10 square x by 2 minus 4 10x by 2 plus 1. Okay, 1 plus 10 square x by 2 is directly sec square x by 2. You already know this formula. Now take this t and write it as 10x by 2. So dt by dx will be equal to what? 10x by 2 will be sec square x by 2. That is, dt will be equal to, and x by 2 also needs to be differentiated. That will come as half. So 2 dt will be equal to sec square x by 2 dx. So this is whole dx. Sec square x by 2 dx can be written as 2 dt now after replacement or after taking t equals to 10x by 2. Denominator will become t square minus 4t plus 1. T is this 10x by 2 has been taken as t. Now we have to make this t square minus 4t plus 1 as perfect square. What is the coefficient of t? Which is 4. Now this divided by 2 is 2, and now you can square it and add it as subtracting. So you can add plus and subtract, add 4 and subtract 4. So a square plus b square plus 2ab t plus t minus 2 whole square. This is not t plus 2 whole square. I'll just change it. So t minus 2 whole square minus root 3 whole square. So you can write it as 2 integration dt divided by t minus 2 whole square minus root 3 whole square. Okay, you already know the formula of integration of dx by x square minus a square. So this will be dx by x square minus a square. It will be 1 by 2a log and x minus a by x plus a. And that has to be in the modulus. And this log is not just log, simple log, it's ln, log base e. That's why you can write it as ln. So 1 by 2a, what is 1 by 2a? 2 root 3 ln, and then you have the modulus sign, and you can write this as x minus a by x plus a. So I'm writing it as t minus 2 minus root 3 and t minus 2 plus root 3. So t minus 2 minus root 3. It's not t plus 2. Please remember, I'm just going to change it. Whatever I'm saying is the correct thing. So now let us write it as 10x by 2. 10x by 2 minus 2 minus root 3 and 10x by 2 minus 2 plus root 3 plus constant of integration. Okay, 2 gets cancelled, you get 1 by root 3. So 1 by root 3 ln 10x by 2, I'll just change it as negative. This is negative. And actually this was t minus 2 whole square as I indicated you earlier. So I'm just changing the sign because it was the actual sign. I have to put it earlier. But anyways, you understand the things now. So 10 square x by 2 minus 2 plus 3, root 3. So this is your final result. This is all minus. Okay, this is the result which I was talking about, and this is the way you are going to write. There are certain things, that is, the explanation will not be like this. It will be more in an exploratory way. That is, I have to explain you a lot. But when you are writing actually for exam or your classwork, you have to write exactly like this, almost like this. Now in this question, we have cos x. So you already know how to convert this cos x in terms of tan. So cos x will be equal to 1 minus 10 square x by 2 divided by 1 plus 10 square x by 2. Now this can be just placed here. So I will just take this 10x by 2 as t just to show you what will come. So 1 by 4 cos x can be replaced as 1 minus 10 square x by 2, that is 1 minus t square, divided by 1 plus t square and minus 1. So this will be 1 by 4 minus 4t square and minus 1 minus t square. Okay, this 1 plus t square in the denominator will go upstairs, that is 1 plus t square. So 1 plus 10 square x by 2 it will be. In the denominator you have minus 4t square and minus t square will give you what? It will be minus 5t square. And 4 minus 1 will give you 3. So you can have a 3 here. 3 minus 5t square. 3 minus 5 10 square x by 2. So now you know this 1 plus 10 square x by 2 is simply sec square x by 2. And this 3 minus 5 10 x by 2 can be written as root 3 whole square minus, and this 5 10 square x by 2 can be written as root 5 10 x by 2 whole square. You just have to make it as a perfect square, even if you have to include a root by yourself. Now, previously we have taken always t equals to 10x by 2 whenever we encounter this. But now we have root 5 10x by 2, and we need to get rid of this in order to make it equivalent to integrable equations we have. So now I'm taking t equals to root 5 10x by 2. dt by dx will be equal to what? Root 5 10x by 2 will be sec square x by 2. And we have to differentiate x by 2 also. That will give you 1 by 2. So this will be root 5 by 2. Now 2 by root 5 will come on left. 2 by root 5 here. And dt this one. And sec square x by 2 dx will come here. Sec square x by 2 and dx. So the numerator, what was that? Sec square x by 2 dx. It will be 2 by root 5 dt. So integration. So sec square x by 2 dx we have written now by placing 2 by root 5 into dt. Root 3 whole square minus t square. Now we have a direct result. You know already the result. Dx by a square minus x square. And that will give you 1 by 2a log ln, basically log base e. And since it is a square minus x square, there will be a subtle change. It will be a plus x by a minus x. So ln and log base e are same. So you can just write ln or log base e. So 2 by root 5 here. Now you can just write 1 by 2a. What is a? Root 3 here. And ln, which is ln or log, it's up to you. You write ln or log base e. Modulus root 3 plus, what was x? It's t basically. But t was taken as root 5 10x by 2. So I'm replacing it here only. And here also root 3 plus root 5. Root 3 minus root 5 10x by 2. Let's resolve this. 2 gets cancelled. Root 5 into root 3. Root a into root b is root ab. So you have 1 by root 15. So this is the final answer. 1 by root 15 ln modulus root 3 plus root 5 10x by 2 divided by root 3 minus root 5 10x by 2 plus constant of integration. Now what steps are there? So this is the steps we are talking about, and you have to follow this, okay? There are certain way you can do. This is another way of doing it which I am showing you. It's not what I have done, because there are certain things which can be done in different way, but the result remains the same because you have to arrive at certain answer, which is now we have 1 by 1 minus sin x plus cos x. So you know how to convert this sin x and then cos x. So just see the denominator first. Since we have already introduced the formulas, I'm writing the formula directly. Sin x will be 2 10 x by 2, 1 plus 10 square x by 2. What will be cos x? Cos x will be 1 minus 10 square x by 2 divided by 1 plus 10 square x by 2. Now what we'll do here is we'll take the LCM. And since we have 1 plus 10 square x by 2 in two terms, we'll write this 1 plus 10 square x by 2. I'm writing this 10 square x by 2 as t square, just for doing it in a short way. So 1 plus t square plus 10 square x by 2 will come here, minus 2 10 x by 2 plus 1 minus 10 square x by 2. So this gets cancelled. 1 and 1 will become 2, and this is 2 minus 2t. Okay, this is the denominator part, that is 2 minus 2t divided by 1 plus 10 square x by 2. Now since 1 is already in the numerator, this 1 plus 10 square x by 2 will go up and it will form as sec square x by 2. 1 plus 10 square x by 2, I have denoted t just as 10x by 2 right now. So it will be sec square x by 2, which goes up. So we have sec square x by 2 dx divided by, what do we get? 2 minus 2t. So you can just take 2 outside, and what is remaining inside? It is 1 minus 10x by 2. Now dx are already there in the numerator. So let's take t equals to 10x by 2. That is the assumption we are taking. dt by dx will give you sec square x by 2. And don't forget to differentiate x by 2 so that you can have a half here in front. And then dx goes on the right. So this equation will form in this way. Half is already there in front of integration. And for sec square x by 2 dx, it will be 2 dt, as you see here also. I told you the explanation why it is 2 dt, because of the sec square x by 2 dx. So 2 dt, 2 already we have taken outside, dt here, 1 minus 10x by 2, 10x by 2 was taken as t. So 1 minus 10x by 2 t you can write. But here is a problem. One mistake I committed. I need to rectify my assumption. You know why? I could have just edited this part and gave you the actual answer. But you need to know what are the problems and how to survive those problems. Now if you take t equals to 1 minus 10x by 2, you will see what is the benefits. What are the benefits? So dt by dx will be, 1 will be 0, negative half sec square x by 2, negative 2 will go on the left, so negative 2 dt. Now this sec square x by 2 dx, which was previously 2 dt, has just transformed to negative 2 dt. That is the only thing changed here. If you take 10x by 1 minus 10x by 2 instead of 10x by 2 as t. Now this sec square x by 2 dx, negative 2 dt, negative 2 we have taken outside, it is dt. Now I tried to do this, but I stopped in between just to show you what is the problems we face. Now when we take 1 minus 10x by 2, it is simply t, and dt by t has a direct integration which is log, which is ln, log base e, modulus of t, 2 gets cancelled, you have negative outside. So minus log, what was t? Remember it was changed to 1 minus 10x by 2. So 1 minus 10x by 2 plus constant of integration. As I indicated you earlier, log is log base e, you can just write it as ln as well. Okay, this is the result which I wanted to highlight because you have to write this in this way exactly. Now this question is also similar to this question, the previous question, and there are certain questions of the same sort, and it's better that I explain you one or two of it which have more importance than the others. I'm not saying there is no importance of this question also. This will come, this may come also. But if you try the hard one or try the popular one, you will always be able to solve the easier one. That's what my thoughts are. So this question is almost similar to the previous two questions we have seen. But I am going to solve this. And the criteria remains the same. The process remains the same. I am taking the denominator right now. So this will be 13 plus 3. In place of cos x, replace it by the tan x by 2 conversion. I am just writing tan x by 2 as t just to make it easier for you to understand. It will be clearer also and easily understandable also. So I am writing cos x as 1 minus tan square x by 2 divided by 1 plus tan square x by 2 plus 4. Sin x can be written as 2 tan x by 2 divided by 1 plus tan square x by 2. So let me write it as 2 tan x by 2, 1 plus tan square x by 2. So let's take the LCM now. 13 into 1 plus tan square x by 2 plus 3 1 minus tan square x by 2 plus 4 2s are 8t and divided by 1 plus tan square x by 2. So this is 1 plus tan square x by 2, and please remember this was just the denominator. It was already having 1 on the up, that is on the upstairs part. So this 1 plus tan square x by 2 will go up. Now let's solve this one. 13 I'm multiplying its sign. 13 plus 13t square, 3 minus 3t square and 8t. So what do we get? 13t square plus 8t. Or rather 13t square minus 3t square will give you 10t square. 8t is already there. There is no other t term. And 13 plus 3 will give you what? It will be 16. Now this 1 plus tan square x by 2 which was in the denominator will go up as 1 was already there. So 1 plus tan square x by 2 is sec square x by 2. And this will go in the numerator. So when we are actually integrating it, we'll start with this sec square x by 2 in the numerator. This is 1 plus tan square x by 2. Let's write it here, sec square x by 2. And this we'll write it here, 10. Now let us take this t as tan x by 2 here to show you what exactly has come. So 10 tan square x by 2 plus 8 tan x by 2 plus 16. And dx is already there. Now are we ready to do this? Because previous question and previous to previous question and few questions we have already done like this, completed like this. Let us take t equals to 10x by 2, dt equals to sec square x by 2, dx half is already there because x by 2 has to be differentiated also. So 2 will go on the left. So this whole numerator can be replaced or can be written as 2 dt, 2 I am taking outside the integration sign. And this will be 10t square plus 8t plus 16. As we see 2 in the numerator, we can do a simple simplification. We can take 2 common from 8t square. If I take 2 common from this, it will be 5t square 4t plus 8 in the denominator. This 2 we have taken out. And when this 2 taken out, 2 is already in the numerator. So this gets cancelled. So you are getting rid of 2 and 2. You don't have any constant right now. So 5t square plus 4t plus 8, which is in the denominator, this can be converted into a perfect square. So how are we going to do this as a perfect square? Let's discuss it again, because you know already how to do this. First of all, we cannot have anything in front of t square, so I'm taking 5 outside. So please remember, whenever I'm taking 5 outside or any term, any constant outside, it will always come in the denominator of the actual term. So I'm taking 5. Whenever you take 5, you don't know what will come inside. Divide everything by 5. So t square plus 4t by 5 plus 8 by 5. In order to make it as a perfect square, take the coefficient of t, which is 4 by 5. Divide it by 2, you will get 2 by 5. Square it and add it and subtract it. So plus 2 by 5 whole square and minus 2 by 5 whole square. So what do we get? A square plus b square plus 2ab. T square plus 2 by 5 whole square plus 4t by 5 is a square plus b square plus 2ab. So it is 2t plus 2 by 5 whole square. Now the other term which is remaining is 8 by 5 minus 2 by 5 whole square. So 8 by 5 minus 2 is a 4 by 25. So it will be, if you take 5 in the LCM, you will get 40 minus 4. 40 minus 4 is 36. 36 by 25. So 36 by 25 can be written as 6 by 5 whole square. So we have got a perfect square here. 6 by 5 whole square you can write. Now this is a perfect square. So the integration has become something like this. There is nothing outside except 5. As I told you, 5 was already taken outside. So t plus 2 by 5 whole square plus 6 by 5 whole square. Right? This is just integration of dx by x square plus a square. This is 1 by a tan inverse x by a. It's not 2a. It's 1 by a tan inverse x by a. What is x here? T plus 2 by 5. What is a here? 6 by 5. So let's write it here. 1 by 6 by 5. That is 1 by a. Tan inverse x by a. T plus 2 by 5, which is x. 6 by 5 is a. And this will, 6 by 5 will become 5 by 6 when it will go up. 5 was already there outside, remember. So 5 is, if it is there, so this 5 gets cancelled here. And we have, 5 was in the denominator. Remember, 5 was not upstairs. It was downstairs. That is why we have cancelled 5. So 1 by 6 tan inverse 5t plus 2 by 5, 6 by 5. 5 gets cancelled. You have 5t plus 2 by 6. What is t? It was tan x by 2. So 5 tan x by 2 plus 2 divided by 6. Now this is inside the bracket plus constant of integration. That's your final result. So this is how it has to be done, and you need to follow all these steps, not exactly like this, in the way the examiner understand what you wanted to present. Now this is a very general question, because we have done a question like this, 2-3 questions where we have some constant also added to the denominator. So I will just show you some other questions. Cos x minus sin x is also there. There is another question which is coming up, which is cos x plus sin x. And there are certain questions which follow the same scheme. So understand one question and try to implement those instructions in the other questions. So let me show you here. 1 by sin x plus cos x. I think this plus will be easier for you. So I am deciding that we will do this 1 by cos x minus sin x in order to better understand the previous question, which is simply 1 by sin x plus cos x. So the same scheme is going to be followed. Please remember. And there are various students, they complain that you always leave the important questions. But the thing is, there are so many questions which are repeated. So I always try to take those questions which needs more effort, so that you understand it better. Those who are requiring less effort can be solved by you, because I am quite confident on your IQ and your logic. We have cos x 1 minus tan square x by 2 by 1 plus tan square x by 2. I am just writing t as tan square x, t as tan x by 2. Just to show you in easier way how to simplify this. Minus sin x, in place of sin x I am writing 2 tan x by 2 divided by 1 plus tan square x by 2. So we will take this 1 plus tan square x by 2 as the LCM. So 1 minus tan square x by 2 minus 2 tan x by 2 has come in the numerator. But this is the denominator. I am saying 1 is already there upstairs. This is just we are dealing with the denominator. So we will try to resolve this, because 1 plus tan square x by 2 will ultimately go to the numerator. Because this was just the denominator, 1 divided by this denominator, so 1 plus tan square x by 2 will go up. And 1 plus tan square x by 2 is simply sec square x by 2, that relation we have been using in this whole exercise. So we'll write like this, 1 plus tan square x by 2, that can be written as sec square x by 2. This is already done. Now we are just left with 1 minus tan square x by 2 minus 2 tan x by 2. Let me write it here. 1 minus tan square x by 2, which is I am writing in place of 1 minus t square minus 2t. So t we will take it as 10x by 2, and this will give you dt equals to sec square x by 2 dx, and half will also come, half 2 will go on the left hand side. So this sec square x by 2 dx can be replaced by 2 dt in this particular equation which I am pointing right now. 2, let's take it outside, dt divided by. Now 1 minus 10 square x by 2 minus 2 10 x by 2, 1 minus t square minus 2t. So the whole thing which is left here is to make 1 minus 10 square x by 2 minus 2 10 x by 2 as a perfect square, which is 1 minus t square minus 2t. So please remember, whenever we are making the perfect square, we don't need any negative sign in front of t square. We don't need any constant in front of t square. We have to get rid of that in any way. So minus t square minus 2t plus 1. Let's take negative outside. T square, all the signs will change. The only thing when we take negative outside is all the sign will change. It will be t square plus 2t minus 1. Now we have minus 1. This is not making a perfect square. So in order to make it a perfect square, take the coefficient of 2, divided by 2, you'll get a 1, add 1 and subtract 1. So I'm adding 1 and subtracting 1. Now this t square plus 2t plus 1, these three terms will form t plus 1 whole square. It's simply a plus b whole square. A square plus b square plus 2ab, a is t and b is 1. And this minus 1 will become minus 2. But we have to make it as a perfect square. So under root 2 whole square, you can just write like this. Now since it is negative outside, you can just replace these two terms, or you can swap these two terms with the sign. And this will form as, this is dt divided by, now let me write it here. Root 2 whole square, I am writing it first because t plus 1 whole square has just become negative. So what is the formula we got? We got dx by a square minus x square. And you already know how to implement it or how to write this in the integrable form. So 1 by 2a, 1 by 2 is already there. What is 2a? A is root 2 here. So 1 by 2 root 2. 1 by 2a log modulus, log is ln only because log base e we are talking about. Modulus of whichever is there, the numerator will become a plus x and the denominator will form a minus x plus constant of integration. Please remember, this has to be kept in the modulus sign because it is inside the log. Now ln is log base e, a plus x. What is a here? It's root 2. I'm writing root 2 here. The numerator has to be added, so plus. Now this t was what? T was 10x by 2. If you remember, t plus 1. So you can just write it as 10x by 2. 10x by 2 plus 1. Root 2 minus 10x by 2 minus 1, because 10x by 2 plus 1 is t. When you multiply it by negative, it will be all negative. So negative 10x by 2 negative 1 plus constant of integration. This whole is the answer, but there is only one thing, 2 gets cancelled. So 1 by root 2 ln modulus of what content is inside is your answer. Okay, this is the way you are going to do this, and this is the same way 1 by sin x plus cos x will be done. So let me just show you how to do this. If you have any kind of problem, just let me know. We will solve it again. But it has a very much strong affinity with the previous question. Now this 5 minus 4 cos x have already been dealt in the previous first and second question. One was having cos, one was having sin in the same form. So I'm just showing you the result. 1 by 2 plus sin x plus cos x. So we have done this question like this. You just have to replace sin x and cos x in terms of 10x by 2, and this will be the result. Now the next question, if you see, this question is the exact question. But there are certain questions which are going to be following this question. So all these questions have the same way, process and technique to complete. So I would like to just present these questions and try to solve the question which is the question number 12. So how to solve this question? The process remains the same. We will convert sin x in 10x by 2 form, same for the cos x also. We already know the formula, so we'll directly write it. Sin x is 2 10x by 2 divided by 1 plus 10 square x by 2. This is your sin x. How about the cos x? It's root 3. This is your 1 minus 10 square x by 2 divided by 1 plus 10 square x by 2. I have just replaced sin x and cos x in 10x by 2 form. So I am writing now 10x by 2 as t just to make it easier for you to understand. I am not actually equating it right now. So 2t by 1 plus t square, all t is 10x by 2 here. 1 minus 10 square by 1 plus 10 square x by 2. So let's take the LCM now. 1 plus t square will be the LCM. And the base is same, so you can just add the numerator, which is actually the denominator of the numerator. 1 is already there in the top. So we are just discussing the denominator. I have multiplied it inside. Now this is 1. So I was talking about this 1 which is already out at the up. So 1 plus tan square x by 2, this goes up, and 1 plus tan square x by 2 is actually sec square x by 2. So let me write sec square x by 2 in place of 1 plus tan square x by 2, which has evidently gone to the top. Now this 2t plus root 3 minus root 3t square, let me write it again in the form of tan x by 2. So 2 tan x by 2 plus root 3 minus root 3 into tan x by 2 whole square. So we have to now differentiate integrate this. So we'll take this t equals to tan x by 2. This is the actual equation which will be replaced. So dt will be equal to sec square x by 2, x by 2 differentiation will be half dx. This 2 will go up, so 2 dt. 2 dt will be equal to sec square x by 2 dx. So numerator can be replaced by 2 dt now. And before we go ahead, we have to look at the denominator now. We have to make it as a perfect square in order to get the proper formation of the formula that can be replaced as the integrable result. So this is negative root 3t square. Let's, in the descending order of the power of t we are writing now. First we need to get rid of anything which is as an exponent of t square exists. Root 3 is there, so we'll take this negative root 3 outside. So t square, if you don't understand how we take outside and what happens inside, just divide everything by minus root 3. Whatever you get, you just write it. So negative root 3 t square by negative root 3 is t square, and 2t divided by negative root 3 will be minus 2t by root 3, and root 3 by negative root 3 will be negative 1. So t square minus 2t by root 3 minus 1. So this this coefficient of t, which is 2 by root 3, has to be divided by 2. You'll get a 1 by root 3. Now just square it. 1 by root 3 whole square and 1 by root 3 whole square has to be added and subtracted. So what do we get here? A square plus b square minus 2ab. So this is basically a minus b whole square. T minus 1 by root 3 whole square. And this negative 1 and negative 1 by root 3 whole square. What are you going to get out of this? Minus minus, you can just take common and just add this 1 plus 1 by root 3 whole square. So you have a 1 here. 1 by root 3 whole square is 1 by 3 only. This will form as 3 plus 1 by 3. So it will be 4 by 3. So let me write it as 4 by 3. So this can be squared like this, 2 by root 3 whole square. So 2 by root 3 whole square, you can just write it here, 2 by root 3 whole square. And this is just the denominator I am talking about. So integration will become like this. Numerator already I told you it can be replaced by 2 dt. 2 I am taking outside. Dt divided by t minus 1 by root 3 whole square minus 2 by root 3 whole square. So now we have a formula of integration of x square minus a square in the denominator. You already know the formula, but let me write it again just for your refreshing of memory. Dx by x square minus a square will be 1 by 2a log x minus a divided by x plus a in the modulus sign. Log is basically log to the base e. You can always write it as a ln. Mathematics people, they know what is log and what is ln. So 1 by 2a. What is 2a? 2 into 2 by root 3. Please remember, negative root 3 was already taken out when we were making the perfect square that I'll introduce just now. So this t minus 1 by root 3 minus a minus, that is minus 2 by root 3, and t minus 1 by root 3 plus 2 by root 3. This modulus ends and plus constant of integration. So root 3 will go up, but still we have a negative root 3 which is outside, which we have taken earlier, if you remember. So you have to introduce that negative root 3. This negative root 3 I am introducing now, and it is in the denominator, please remember. So negative remains there, root 3 gets cancelled, 2 gets cancelled, so we have negative 1 by 2. So minus half it is. Now if there are 3 ways. See, minus log x is simply log 1 by x, because this negative outside the log will come as the power of x, and power of x to the power negative 1 or x to the power minus 1 is 1 by x only. So if you replace this negative, this denominator and numerator will swap. So t minus, this is negative 3 by root 3. In denominator it will be t. 2 minus 1 is 1, so 1 by root 3. Now you can just multiply root 3 numerator denominator, or you can take root 3 outside. That's the same thing. So root 3t, and this gets cancelled. Root 3t minus 3, root 3t plus 1. This goes up, this goes down, because negative has been taken inside. What was t earlier? Tan x by 2. So root 3 into tan x by 2, and plus 1 goes up. So root 3 tan x by 2 minus 3 in the modulus sign plus constant of integration. So this is the final result which we were talking about. Okay, this is the result. This is the final result, and you need to write almost like this. The clarity, the different assumptions we have taken, the different formulas we have employed, all that needs to be registered here in order to give a complete solution. Now the next question, as I indicated earlier, they are almost similar. They will not have any other technique. Same sin x and cos x has to be converted into tan x by 2, and rest you know because we have already had the 14th question from the beginning. Now these are certain questions which I have highlighted. Some of them we have done, some of them we haven't. But since we have done these type of questions already, I'm just showing it to you. You can just turn your page back and try to revisit these questions. But because this is the last question, this is my duty to start well and end well. So I am going to solve this question. Those who haven't understood yet, they can benefit from this solution. So I'm taking the denominator and I will convert this cos x and sin x into tan x by 2. So 7 into, what is cos x? Now tan x by 2, I'll just represent it right now with a t, just to make it simpler to understand. So 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Sin x will give you 2 tan x by 2 by 1 plus tan square x by 2. Now take the LCM now. Please remember that we are just dealing the denominator right now. So 1 plus tan square x by 2. Now 5 into 1 plus tan square x by 2 will come. Other things remains the same. So I'm multiplying right now 5 into 5t square and 7 minus 7t square and plus 2 tan x by 2. What do you get? 5t square minus 7t square will be negative 2t square. It's actually negative 2 tan square x by 2. This gets cancelled. Now 2t you can write, and 5 plus 7 is 12. Now this is the denominator because we already have 1 plus tan square x by 2 in the denominator. And this all is denominator because 1 is already upstairs. So this 1 plus tan square x by 2 goes up. This will form sec square x by 2 because 1 plus tan square x by 2 is obviously sec square x by 2. Now integration will become something like this. Minus 2 tan x by 2 plus 2 tan x by 2 plus 12. Plus 12 like this. Now let's take this is the actual taking of t equals to tan x by 2. dt will be equal to, you already know about that, 2 dt will be equal to sec square x by 2 because all the questions we have done has the same assumption. We'll write 2 dt in place of sec square x by 2 dx. In the denominator, what are we going to get? So minus 2t, I'm taking the denominator, okay? Minus 2 tan square x by 2 plus 2 tan x by 2 plus 12. The best thing is that you can just take negative 2 outside because we don't need anything in front of t square. It has to be away from any other thing except t square. So when you take this negative 2 outside, if you don't know how to do the other terms, just divide negative 2 with every term inside. So we'll get this t square minus 2 minus t minus 6. Now here will be a surprise for you. The surprise is that t square minus t minus 6 is factorable. What does it mean? 6 can be written as 2 into 3. T square, you can just write it as negative 3t plus 2t minus 6. If you take this t common, t minus 3 will come inside. You can take 2 common, t minus 3 will come outside. So you have a factor t plus 2 and t minus 3. Would you like to go ahead with the factors, or would you like to stick to all the techniques we have learned up till now? So this is the separate thing which I am just trying to explain you, because we can deal this question with the t minus 3 into t minus 2, but we don't want to do it. You know why? Because we are accustomed to certain kind of solving which we have done until now. So what we'll do, we'll take the coefficient of t, which is 1, divided by 2, which is half, square it, add in and subtract it. So plus half square minus half square. So I'm just keeping my eyes closed. I don't want to see this t minus 3 into t minus 2. I've done this as a perfect square. T minus half whole square, which is t square plus half square minus t. And 6 and half square, that has to be added. This will give you 24 plus 1 by 4, which is 25 by 4. And this will give you 5 by 2 whole square. Now what do you get? Sec square x by 2 dx was already, you know that it can be written as 2 dt. Negative 2 we have taken from the quadratic equation, and this is 2 dt. 2 is already taken outside, dt is there. Negative 2 from the quadratic equation, t minus half whole square minus 5 by 2 we just got by making it as a perfect square. This gets cancelled, negative is there already. Now when you have a negative, you can just multiply it inside and you can swap these two terms. So now this will be, it was initially x square minus a square, but now it has become a square minus x square. And we have the direct formula for dx by x, a square minus x square, which is 1 by 2a, this is under ln log. So x minus a by x plus a in the modulus plus constant of integration with a log sign. I just forgot to write that ln sign. You know it. So 1 by 2a. What is 2? A is 5 by 2. Log modulus of 5 by 2 plus t minus half and 5 by 2 plus minus, because see, I already told you it's a square minus x square. So when you multiply it by negative, it will be minus t plus half. This is simple algebra, okay? We have already done the question because we are just arriving at the answer right now. 2 gets cancelled, you'll get 1 by 5 here. Ln 5 by 2 minus half is what? 5 minus 1 by 2, which is 4 by 2, 2. 5 by 2 plus half is 6 by 2, which is 3. And t was what? 10x by 2. So write this 2 plus 10x by 2. You can write in this way. So 3 minus 2 in the denominator, which is t has been replaced by 10x by 2 plus constant of integration. That's your final answer. So this is the actual reference for you. You can just hold on to it if you are actually solving it by yourself. The most important thing is cos x and sin x, this formula, if you learn by heart how to make the perfect square. I told you that this can be made as a factor, but we didn't do it. We didn't do it because we wanted to solve it in the way we have just learned. So this is all about this exercise. Thank you so much. Have a good one.